Hey guys, I've had a couple of questions about beta decay. I've had a couple of people that are a little bit confused about some of it, and I thought I would give a few more examples for those of you that are a bit just like not sure where to go. The main reason why there's a confusion is because beta decay is one of the only ones where there are two types of beta decay: beta minus decay, beta plus decay. Beta minus decay is the more common one, but you will still sometimes see beta plus decay. Why is it called minus decay? Because it makes an electron, which is minus charge, whereas plus decay creates a proton, which is plus one charge. Now, why does it need to make an electron? It makes an electron because you're making a proton, which is positively charged. And so you need to balance it out. You might say, well, why does this one need to be a plus one charge? Because if you turn a proton into a neutron, you're actually losing a plus one charge, which is like minus one. And if you lose a plus one, it's like minus one. So what I'm going to do is I'm going to hit you with a couple of examples with beta minus decay and a couple of examples with beta plus decay, and hopefully that'll help out some questions. So let's grab a look at this first one here. Nickel and copper. So first things first, this is beta decay. How do I know that it's beta decay? Because the mass is the same. In beta decay, you'll notice that the proton becomes a neutron, but you don't lose anything. There's no loss of mass. So in beta decay, there is no loss of mass. That's my first clue. The other clue that I have is that I know that the amount of protons is changing. I'm going from 28 to 29. That's a change in the number of protons. So I now have more protons than I started with. So in order to balance this out, I need to have a minus one charge here. That minus one will balance out this 29 because we all know that 28 is 29 minus 1. But if I put a minus one charge here, I need to attach that to a particle. Let's put an electron. But with beta minus decay, we've got to remember that we have an electron and an antineutrino. So let's just shove an antineutrino on the end, and we're done. That's that first one done. Just a quick reminder, let's just check that everything here is balanced. How do we do that? Let's check the top numbers. 63, 63, 0, 0. So 63 equals 63 plus 0. Perfect. 28 on the bottom. 28. Got 29 here, but 29 minus 1 is 28. Everything is balanced. Let's look at this second one. Second one here, we've got technetium. Now, technetium is undergoing beta decay. So how do we know it's undergoing beta decay? Because here we've got an electron and here is an antineutrino. Job done. So let's now add in the extra thing that's left over. So if we've got undergone beta decay, that means we've got more protons. Beta minus decay means we've got more protons. So that means we must have 43 to 44 protons. The other way you can check this is you can go, well, 43, whatever, we've got a minus 1, so 44 minus 1 is 43. Now, I've already said the mass number doesn't change, so 98, we've got 0, 0, so that's balanced. Top's balanced, the bottom's balanced, we're done. All we need to do now is work out what element that is, and it just so happens that I have a periodic table sitting next to me. A quick look at periodic table. If I go for element 44 on the periodic table, that is very tiny, difficult to read, but it looks like it's ruthenium. Ru. Perfect. So that's 2 done. Let's do one more. Bismuth. Now with the bismuth one, I just said, you know what? It does beta minus decay. Figure it out. So I haven't even given myself very much room here. So let's see if I can fit this in. I don't think I can, so I'm going to do it underneath. So bismuth, if I know it's undergoing beta decay, then I know that it's beta minus decay. that means that I have to be making an electron. So let's chuck the electron in first. Electron has a -1 and a 0. In order to balance that with the 83, I'm going to have 84 on the bottom here. Now, if I've got an electron, I need an antineutrino, so let's just put that on at the end. And in the middle, I just need to find out, well, what I've already got the amount of protons, 84. So one of these neutrons has turned into a proton, so it's got one more proton now. But the mass is still the same. We haven't lost any of our protons. It's still the same. 214. And then bismuth. What is the 84th element of the periodic table? We'll get my periodic table out again. I look for 84. 84, 82 is lead, bismuth. We've got polonium here. PO for polonium. Let's check to see if this is balanced. 214 on the top. 214 plus 0, 0. That's balanced. 83 on the bottom. 84. But I've got a -1 here. So 84 minus 1 is going to be 83. That is balanced. So that's beta minus decay. What's the trick with beta minus decay? Make sure that you remember that the tops and the bottoms are balanced. You also just need to remember that, yeah, it's just an electron. What about beta plus decay? I've got 2 examples of beta plus decay just because it's important to have both of them here. Let's talk about beta plus decay. On the top, we've got nitrogen, which is going into carbon. Now, when nitrogen turns into carbon, we've got 7 protons turning into 6. We need an extra positive charge. So let's put that extra positive charge here as a +1. Okay, so we've got a +1 charge. We know that the masses is the same, so it's going to be 0. So let's just call this an anti-electron or a positron. Job done. Not quite. We've also got to add in a neutrino. Now, not an anti-neutrino because we've already got an antiparticle. We just need to do a regular neutrino. And that's it. That's all we need to do. Let's check that this is balanced. So, checking if it's balanced. 14 on the top. 14 plus 0, 0. That's balanced. On the bottom, we've got 7. On the left, right, we've got 6 plus 1, which is 7. So, therefore, that is balanced. For the last one, we've got oxygen. And again, I haven't given myself enough room, but that's okay. I'm going to do it underneath. We've said that oxygen is going to undergo some kind of beta plus decay. If it's undergoing beta plus, then that means I need to have an anti-electron on this side of the equation. I also need a neutrino. Let's put that straight in there. So then, if we know we've got +1 here, and it has to equal 8, then whatever this must be, this will have to be 7. The atomic masses need to be the same, so 15, and what did we know? That's going to be nitrogen. So we've got nitrogen here. Now let's double check this works. We've got 15 on the top, 15, 0, 0. So the top is balanced. At the bottom we've got 8. 7 plus 1 makes 8. This is also balanced. Ladies and gents, I hope that has actually given you guys a little bit more information on how to solve one of these types of questions with beta decay. And hopefully it's given you a good idea of what's the difference between beta plus and beta minus. The main trick to know whether or not you're dealing with beta plus or beta minus is to look at these numbers. If the numbers are going down, then you'll need a plus charge to balance it out. If the numbers are going up, then you'll need a minus charge to balance it out. And then you just got to put the other things around it, put the electrons around it, put the antineutrinos around it, put the zeros where they need to be. I hope that has cleared up some questions. If not, please feel free to send me another email. Thanks guys, bye.